Here I'm going to illustrate the concept of inheritance and polymorphism. More specifically, I'm going to illustrate the concept of inheritance through the use of abstract classes. To illustrate this, let us consider the sound of the cries of humans, dogs and rooster. We all know that all these animals have their unique sounds of cry. For example, a human cry may sound like wah wah, wah wah, whereas a dog's cry may sound like woof woof, and a rooster's cry may sound like co co co. From this example, we observe that humans, roosters and dogs all cry, but the way they cry is different from one another. If we model this in Java, we may specify a class for each object of a rooster, a human and a dog. This is shown here. So we have a class dog, a class rooster, a class human, and each one of them has got a method cry. Observe that the definition of the method has the sound of the cries of the dog, the rooster and the human. Now if we want to invoke the cry methods, we may write a tester class as is shown here, and then create an object of each of those animals. Thus we may individually invoke the cry methods on each type of objects. This is cumbersome to do when we have lots of objects of nearly the same type except for a few minor differences. Hence a better way is to use the principle of inheritance and polymorphism, which is explained next. On observing the three classes, we notice that the cry method is common. So we have a cry method here, a cry method here, and a cry method in humans. So it is common to the three classes, hence it may be placed in a superclass. Let's call this superclass animal. Your first impression of an animal class may be as follows. So this may be your first impression of an animal class. However, this will not help since we want to only sound the cry of animals depending on the individual type and not the sound of the cries of all types of animals. This means that though the animal class requires a cry method, we will not be able to define the cry method because the sounds of the cries depends on the actual type of animals. We may do this by specifying cry as an abstract method. That is, an abstract method specifies that there is a need for a method with a specific signature, but its definition cannot be provided since it is dependent on an actual instance types. Moreover, if a class has at least one abstract method, the class itself is defined as abstract. In Java, this is shown as follows. Observe that the keyword abstract in the method as well as at the class level. An abstract class may have other non-abstract methods, but in our example, we only have one abstract method cry. Further, an abstract class, furthermore, since an abstract class has at least one method which is not defined, now remember this is not defined, an abstract class cannot be instantiated. That is, we cannot create an object of abstract class. That is, we cannot write a statement such as this because animal class is abstract, and it is abstract because this method cry with whose definition is not provided. Only the signature is provided, but the definition is not provided. So carrying on, once the abstract class is defined, we may now define each of the other classes as follows. So we may have class human, but this time we use the keyword extends to identify that it is a type of animal. Similarly, we have the dog class, which uses the keyword extend, and the class rooster, which uses the keyword extends. So observe that the use of the extends keyword to signify inheritance in Java, that is, the extends keyword is same as the is a relationship in UML. Also observe that each of the inherited classes, namely human, dog and rooster, should have the complete definition of the cry method. That is, if there is no definition of the cry method provided, each of these classes will in turn be abstract. We are now ready to illustrate polymorphism. Polymorphism means the condition of occurring in several different forms. In our example, it means that an animal object may behave in different forms. That is, if it is an human object, then the behavior of cry is different from the behavior of cry from that of a dog. Yet, they are all of animal kind, with cry being a common behavior. In Java, this may be written as follows. Observe that the left-hand side of the equal to operator is of type animal. So, an animal is of type animal, whereas the right-hand side is of type human in the first statement, in this statement, and it's of the type dog in the second statement. This is permissible because at compile time the compiler knows that human is a type of animal due to the extends keyword in the class definition of human. By a similar token, a dog is a type of animal too. And at runtime, the Java virtual machine observes that an animal actually refers to an object of human. Hence, it will invoke the default constructor of the human class when the new human statement is invoked. Similarly, we can also observe that another animal references the object of the dog class, so it invokes the constructor of the dog class when the new dog statement is invoked. This is an example of polymorphism. That is, at runtime, it invokes the behavior of the appropriate object. The utility of polymorphism will be apparent in the following code. Here we have all animals as a reference to an array of animal type. However, the right hand side is made of objects of various animal kind. For example, the first object is of type human, the second object is of type dog, the third object is of type rooster, and the fourth object is of type dog again. Hence, it's easier to use a for loop to invoke the cry method of each of the animals. So in the for loop, each animal is of type, each object is of type animal. So we could write this as animal using the for loop notation, and within that object, when each animal at runtime would invoke the appropriate cry method of the object type. For example, during the first iteration, an animal refers to human, so it will invoke the cry method of the human object. Secondly, second time onwards, when an animal refers to a dog object, and Thus, this invocation will invoke the cry method of the dog class, and so forth. The complete code with inheritance is now shown here. So we have an abstract class. Animal, in which we have an abstract method cry, for which no definition is provided, thus making animal an abstract class. Then we have class human, which extends animal, which is same as the is a relationship in UML. Similarly, we have the dog class and the rooster class, and each of these classes have their concrete definitions for the cry method. And in the tester class, we are now using polymorphic behavior to refer to objects of individual kinds, though the left hand side is of type of a reference to the generic kind. For example, the reference of an animal's reference type is an array of animal and not an array of human, or array of dog, or array of roosters, or array of dogs. So it is an array of animals. But at runtime, the system knows that each of these objects refer to the appropriate type, hence the cry method of the appropriate object gets invoked. Hence the output of this code would be human cries sounds like wah wah. This is because the first object is of type human, the second object is of type dog, the third object is of type rooster, and the fourth object again is of type dog. So that's why this has been repeated. So that is an illustration of polymorphic behavior.